Hey guys, let's talk about how to use OSSFS data volumes to share WordPress attachments. This lecture would introduce how to share WordPress attachments across different containers by creating OSSFS data volumes in Alibaba Cloud Container Service. Scenarios. Now, Docker containers simplify WordPress deployment. With Alibaba Cloud Container Service, you can use an orchestration template to deploy WordPress with one click. In this example, the following orchestration template is used to create an application named WordPress, as you can see on the screen right now. Now this application contains a MySQL container and 3 WordPress containers. The WordPress containers access MySQL by using a link. The alien.routing.port 80-HTTP WordPress label defines the load balancing among the 3 WordPress containers. In this example, the application deployment is simple and the deployed application is of complete feature. However, the attachments uploaded by WordPress are stored in the local disk, which means they cannot be shared across different containers or opened when requests are routed to other solutions or container. Coming on to the different solutions, this document introduces how to use OSSFS data volumes of Alibaba Cloud Container Service to share WordPress attachments across different containers without any code modifications. Now, OSSFS data volume, a third-party data volume provided by Alibaba Cloud Container Service, packages various cloud storages such as object storage services, which is OSS, as data volumes and then directly mounts them to the containers. This means the data volumes can be shared across different containers and automatically remounted to the containers when the containers are restarted or migrated. Okay, let's talk about the procedure. First, create OSSFS data volumes. Log on to the Container Service console. Click Data Volumes in the left side navigation pane. Select the cluster in which you want to create data volumes from the cluster list. Click Create in the upper right corner to create a OSSFS data volume. And for how to create OSSFS data volumes, just refer my resource attached to create an OSSFS data volume. In this example, the created OSSFS data volumes are named WP_upload. Container Service uses the same name to create data volumes on each node of a cluster. Use the OSSFS data volumes. The WordPress attachments are stored in the /var/www/html/wp-content/uploads directory by default. In this example, map OSSFS data volumes to this directory and then an OSS bucket can be shared across different WordPress containers. Log on to the Container Service console. Click Application in the left side navigation pane. Select the cluster used in this example from the cluster list and click Update at the right of the application WordPress created in this example, as you can see on the screen. Now in the template field, add the mapping from OSSFS data volumes to the WordPress directory. Note, you must modify the version, otherwise the application cannot be redeployed. As you can see on the screen, click OK to redeploy the application. Open WordPress and upload attachments. Then you can see the uploaded attachments in the OSS bucket. Okay, Let's talk about how to use Docker Compose to test cluster network connectivity. Now, this document lecture provides a simple compose file used to realize one-click deployment, and you can test the container network connectivity by visiting the service access endpoints. Scenarios. Now, when deploying interdependent application in a Docker cluster, you must make sure that the application can access each other to realize cross-host container network connectivity. However, sometimes containers on different hosts cannot access each other due to network problems. If this happens, it is difficult to troubleshoot the problem. Therefore, an easy to use compose file can be used to test the connectivity among cross-host container within a cluster. Coming on to solutions. Now, use the provided image and orchestration template to test the connectivity among containers. This example uses Flask to test the container connectivity. The preceding orchestration template deploys a web service and a Redis service. The web service contains 3 Flask containers, and these 3 containers will be evenly distributed to 3 nodes. When started, the 3 containers are on different hosts, and the current network can realize cross-host container connectivity if the containers can ping each other. The Redis service runs on one of the 3 nodes. When started, each Flask container registers to the Redis service and reports the container IP address. The Redis service has the IP addresses of all the containers in the cluster after the 3 Flask containers are all started. When you access any of the 3 Flask containers, the containers will send ping command to the other 2 containers, and you can check the network connectivity of the cluster according to the ping command response. Coming on to procedure. Now create a cluster which contains 3 nodes. In this example, the cluster name is test link. For how to create a cluster, we can go to resources and we can check for how to create a cluster. But a point to note here, select a create a server load balancer instance when creating the cluster. As you can see on the screen, use the preceding template to create an application. In this example, the application name is again test cluster link to deploy the web service and Redis service. For how to create an application, see create an application as I have attached in the resources. On the application list page, click the application name to view the created services, as you can see on the screen. Click the name of the web service to enter the service detail page. You can see that the 3 containers, which are test cluster link, web1, test cluster link, web2, test cluster link, web3, are all started and distributed on different nodes, as you can see on the screen now. Now visit the access endpoints of the web services as shown in the following figure. This one. The container test cluster link web1 can access the container test cluster link web2 and container test cluster link web3. Refresh the page as shown in the following figure. The container test cluster link web2 can access the container test cluster link web1 and the container test cluster link web3. As the preceding results show, the container in the cluster can access each other. Log. Let's talk about use ELK in container service. But before that, a brief background. Logs are an important component of the IT system. They record system events and the time when the event occurred. We can troubleshoot system faults according to the logs and make statistic analysis. Logs are usually stored in the local log files. To view logs, log on to the machine and filter keywords by using grep or other tools. However, when the application is deployed on multiple machines, viewing logs in this way is inconvenient. To locate the logs for a specific error, you have to go on to all the machines and filter files one after another. Now, that is why concentrated log storage has emerged. All the logs are collected in the log service, and you can view and search for logs in the log service and even do analysis. In the Docker environment, concentrated log storage is even more important compared with the traditional operation and maintenance mode. Docker usually uses the orchestration system to manage container. The mapping container and host is not fixed, and container might be instantly migrated between hosts. You cannot view the logs by logging onto the machine, and the concentrated log becomes the only choice. Container service integrates with Alibaba Cloud Log Service and automatically collects container logs to log service by using declarations. However, some users might prefer the ELK, which is Elasticsearch plus Logstash plus Kibana combination. This lecture introduces you how to use ELK in container service. Now, before we proceed, a quick view of overall structure. As independent Logstash cluster needs to be deployed, Logstash is large and resource consuming, so we do not run it on each machine, not to mention in every Docker container. To collect the container logs, syslogs, logspout, and filebeat are used. You might also use other collection methods. To try to fit the actual scenario, two clusters are created here. One is the test tech cluster for deploying ELK, and the other is app cluster for deploying application. Okay, so with this, I am pausing to end this lecture. In the next lecture, I would be talking about the procedure of the same. Till then, thank you very much.